your point.
For the first function, it's f of x equals x, and the domain is negative infinity to infinity, and so is the range. And the symmetry is odd, and it's not bounded.
There are no horizontal or vertical asymptotes. There's no holes in the line. It's continuous all the way at all points. There's no holes. From negative infinity to infinity, the function is increasing. There is no extrema, and the end behavior as the limit of f of x approaches infinity equals infinity, and the limit of f of x as x approaches negative infinity is negative infinity.
For the quadratic function where f of x is equal to x squared, the domain is negative infinity to infinity, and the range is 0 including to positive infinity.
There's an even symmetry, and the graph is bounded below. There isn't a horizontal asymptote or a vertical asymptote. The graph is continuous at all x. There aren't any holes. From negative infinity to 0 including 0, it's decreasing, and from 0 including 0 to infinity, it's increasing, and there's an absolute minimum of 0 at x equals 0.
You didn't move the
For the quadratic function, the end behavior is as x approaches positive infinity, it equals infinity, and as x approaches negative infinity, it also equals positive infinity.
next paper.
For the cubic function, the equation is f of x equals x to the third, and that's a graph. And we found the symmetry to be odd because f of negative x equals negative f of x, and it isn't bounded, and it doesn't have any asymptotes, and it's continuous at all x because it doesn't have any asymptotes or holes.
It's increasing from negative infinity to infinity. There are no extrema. The domain goes from negative infinity to infinity, and so does the range. For the end behavior, the limit as x approaches infinity is infinity, and as x approaches negative infinity, it's negative infinity.
For the parent function, f of x equals 1 over x, it's the graph. The symmetry is odd, and the boundedness is not bounded.
The asymptotes for this function are x equals 0 and y equals 0. It has an infinite discontinuity at x equals 0, and it's decreasing from negative infinity to 0 and 0 to infinity, and there are no extrema.
The domain of the function goes from negative infinity to 0, where 0 is not included, and it goes from 0 to infinity, where 0 is also not included. The range goes from negative infinity to 0, where 0 is not included, and to 0 to infinity, where 0 is not included. The end behavior, the limit of the function is 0 as x approaches infinity, and the limit of the function is 0 as x approaches negative infinity.
The domain is of this function is from 0 to negative infinity, and the range is from 0 to infinity, and the limit as x approaches infinity is infinity, and the limit as x approaches negative infinity does not exist.
Right. The symmetry is not. There is no symmetry. Just bounded below. Asymptote. There is no asymptote. Discontinuous is continuous, increasing 0 to infinity. Absolute minimum of 0 at x equals 0.
The domain is negative infinity to infinity. The range is 0 to infinity. And then the symmetry is none, and the boundness is below. And the asymptotes is y is equals to 0.
There's the discontinuity is continuous, increasing from negative infinity to positive infinity for y equals 2 to the power of x, decreasing from negative infinity to positive infinity for y equals 1/3 to the power of x, and there's no extrema.
Okay, this is a logarithm function, also known as logistics. There is no symmetry, it is not bounded, there are no asymptotes, and it's a continuous function. A logarithm function also always goes to the point 1, 0.
The logarithm functions increase from 0 to infinity, but they never actually start at 0. They don't touch 0, start close to it, go to infinity, and they don't decrease. There are no extrema. The domain is from 0 to infinity. The range is from negative infinity to infinity. And again with the domain, it again does not touch 0. And the limit as x approaches infinity is infinity. And the limit as x approaches negative infinity does not exist.
The function, the absolute value of x, has even symmetry, and it's bounded below. It has no asymptotes, and it is continuous. And it increases from 0 to infinity and decreases from negative infinity to 0.
The extrema is the absolute minimum of 0 at x equals 0. The domain is from negative infinity to infinity. The range is from 0 to infinity. The limit of x as x approaches infinity is infinity, and the limit of x as x approaches negative infinity is infinity.
So function number 9 is the greatest integer function. It is defined as f of x is equal to the integers of x. The domain is all real numbers from negative infinity to infinity. The range is y such that y includes all elements of integers. There's no symmetry and is not bounded.
There are no asymptotes. There are discontinuities. It jumps at every element of an integer. Increasing and decreasing increases from negative infinity to infinity, and there are no extrema. And behavior, limit of f of x approaching infinity is infinity. Limit of f of x approaching negative infinity is negative infinity.
The parent function 10 is the logistic function, defined as fx equals 1 over 1 plus e to the negative x power. There's no symmetry and it's bounded. The isotopes are y equals 1 and x equals 0.
Okay, there are no discontinuities. It increases from negative infinity to infinity. There is no extrema. The domain is negative infinity to infinity, and the range is 0 to 1.
The end behavior is a little limb f of x, so that x to infinity is equal to 0, and then x to negative infinity, or x to infinity is 1, and x to negative infinity is 0.
Okay, so for parent function 11, the domain is negative infinity to infinity.
The range is -1 to 1, both included.
The symmetry is odd.
It is bounded.
There are no asymptotes.
It is continuous, and the absolute maximum of 1 and absolute minimum of -1.
The difference between the two types of functions is the y-intercept. The sine has a y-intercept at the origin, while the cosine has a y-intercept at 1.
And the limit of f of x is x approaches -infinity and x approaches infinity, so the limit does not exist.
So for the next function, the domain is also -infinity to infinity.
The range is also -1 to 1, both included.
The symmetry is even.
It is bounded.
There are no asymptotes.
It is continuous. It has an absolute maximum of 1 and absolute minimum of -1. And the limit of f of x is x approaches -infinity and x approaches infinity, so it also limit does not exist.
Woohoo! Okay.